Thank you so much. Good afternoon. Again, Tobia Di Pisa from GeoSolutions. I'm going to present how to leverage open source tools for creating 3D tiles. This is the agenda. First of all, I would like to focus on providing a brief overview of what the digital twin toolbox is. So a brief recap, and then doing a kind of year-in review to show you what was delivered basically during the last year. And the main focus part of this presentation is basically related to the proof of concept we have done for integrating the digital twin toolbox into geOrchestra, as well as the ongoing works that we are working on at the moment. So let's proceed quickly, providing an overview of the digital twin toolbox, which is aimed at supporting effectively conversion pipelines for obtaining 3D tiles, providing all tools for inspecting, accessing, managing in general the input data set, managing tiles and many other functionalities. Initially born to support shape files and LAS files for converting them into 3D tile. So the main objectives are effectively process common data sources, providing a well-known driven set of processing scene and methodology for inspecting, assessing, previewing dataset, input dataset, and most important, all using open source tools, okay, and Docker. So here we can see together a really quick overview of the digital twin toolbox architecture, just to highlight its main parts. We can see how it is both front-end and back-end modules are organized with a modular Docker architecture. There is fast API for managing back-end services, MapStore as usual for the preview, and Celery and Redis for the asynchronous job handling. So the digital twin toolbox at the moment is supporting shape files, LAS files, TIFF files, and GLB as an input file format, data format. Of course, the output is having 3D tiles ready for visualization, and there are two different kind of previews that can be managed. The quick one using a Cesium.js viewer for a quick data preview for further assessing the processed data, as well as MapStore, the MapStore one for seeing the final result of the processing chain. These are the main workflows currently supported, where we can see that effectively shape files and point geometry and the polygon and line string geometries are differently managed because basically we have identified better tools for assessing and managing input data according to the topology, as well as point cloud, which is another input data with its own processing workflow. So during the last year, and especially from the last geOcom, we have delivered 2 release candidates. So the first one was mainly aimed at providing a more advanced and complete UI and more user-friendly UI for managing processing pipelines, while the second one is mostly for further improving the current capabilities with a few bug fixing. So in the advanced, if you remember from last year, there was a quite simple and essential minimum UI for managing processing workflows. So with the latest versions, we have included a more advanced UI for increasing, of course, the user experience and provide more capabilities for managing processing pipelines with a better driven UI for reaching all section of the digital twin toolbox. For managing users, and there is, as you can see, a side menu where all different parts of the application can be accessed for uploading data sets ready for the processing, for managing pipelines with a control of the processing status. Multiple asynchronous processing pipeline can be managed together, okay? So simply selecting the uploaded asset related to the processing pipeline the user wants, it is possible to start it and manage it. And of course, there is an embedded MapStore viewer directly connected to the volume where 3D tiles are generated in order to visualize them. They are directly reported available in the catalog tool once they are processed. So the digital twin toolbox integration with geOrchestra is something we have considered to do because in our opinion geOrchestra can somehow benefit of this integration in order to enrich the native 3D processing capabilities, leveraging, of course, on the digital twin toolbox once, and the robust tools provided by the digital twin toolbox for geOrchestra administrator. Of course, Docker-based portability is for an easy testing is something needed, of course, and we have also considered to implement a really simple extension for loading processed 3D tiles directly in the MapStore geOrchestra viewer. So the main objectives of this proof of concept are, of course, to integrate the digital twin toolbox in the geOrchestra stack. Of course, there is we have dropped out the native user management system of the digital twin toolbox in order to integrate it in geOrchestra. There is no, at the moment, integration with the user role management system of geOrchestra, but we have configured it in order to be available only to super users, okay? And there is a shared volume available, reachable from the overall geOrchestra SDI for hosting 3D tiles, process the 3D tiles, of course, and as well as the extension I've mentioned before for visualizing them in MapStore. So we can provide a sample workflow. I can provide, sorry, a sample workflow to see, to provide you a picture of how this integration works briefly. So of course there is the login and access. The initial step is that one, where you need to log as administrator. So then you can upload your asset. In this example, we can see the last file we uploaded. All data you are seeing here in this presentation is coming from the tutorials we have in the wiki page of the Digital Twin Toolbox repository. After the asset is uploaded, you can access the pipeline section for selecting it to start working on the processing pipeline itself, where in the control panel there are many options for controlling the process itself, and they are depending on the type of the input data you have provided for the processing pipeline. So they can differ, for example, between last file or vectorial file, but in general you can, for example, select a TIFF file if you have previously uploaded that assets for coloring, for colorizing the last file. You can manage, for vector file, you can manage the maximum feature per tile, the level of detail, the geometric error, as well as you can directly control the formulas from UI in order to calculate basing on feature attributes, available feature attributes, the upper and lower limits of geometries, and of course you have and many more, of course. And of course, you have a 3D viewer in order to manage, assess, and inspect geometry according to the manipulation that you are allowed to do through the control panel. So in the step 4, as soon as the process finalizes, there is the UI shows you an URL where you can directly click in order to open a really minimum and essential Cesium.js preview for further assessing the processed data. You can also download the final 3D tile, or you can click on the map link in the sidebar menu to directly open it in MapStore. Of course, the final step can be the one for including, for loading the processed data in the in the main geOrchestra viewer. So there is all processed data. As you can see, it is a very minimum tool for simply listing all processed 3D tiles. They appear disabled during the ongoing processes, pipelines. As soon as the pipeline is completed, you can, it become enabled basically so that you can click on it and automatically load the 3D tile in map. So I would like to point out what we have done precisely. So in the terms of which kind of component we have touched for this integration. You can see them here in the list. So the the geOrchestra Docker, header, HD docs. We have of course, a fork of the geOrchestra Docker repository where we have created a custom branch for this, specific to this integration, with a README file containing all the instruction for a quick start and so on. And there is also a dedicated repository for the Digital Until Toolbox catalog that is the MapStore extension for browsing and loading processed 3D tiles in the main geOrchestra viewer. So the integration, of course, is not complete, okay? But it is working, okay? You can already use it. And of course, here I have reported a few ideas, okay, of what can be done in order to improve it and maybe complete it. For example, an integration with the user role management system of geOrchestra, handling permission of processed 3D tiles, and the other one that you can see. I mean, there can be also other ones, of course. So what about the ongoing works? For the next release, we are actively, as you can see, the next slides. In the next slides, you see when we expect to deliver this. Basically, we are actively working on providing support for processing. For new workflows, for providing new workflows. Of course, one of them is providing support for an extensive processing of 3D tiles meshes, okay? So the main object is, as of course, the manipulation and management of metadata, the photogrammetry outline, the generation of sparse and dense point clouds from nidiral and oblique images, okay? Aimed at generating, of course, the 3D mesh as well as the texturing, of course. The main challenges are quite clear here in the list, so it is quite difficult to find a balance between quality and the processing time, even if the best result really depend on the quality of the input data, okay? But yeah, effectively processing that kind of data require a significant amount of hardware capabilities and basically time. Okay, so we are obtaining concrete first result with this. As you can see here, and thank you for the municipality of Florence, which is that provided the data set we are using for this case study. There are a few images showing the various steps of the process, starting from the generation of the dense point cloud, which is bringing to the mesh, then the textured one, and the final 3D tile mesh. There are also other things we are working on. Some of them started last year. I have provided some mention in the last presentation during the last geocom. One of them is, of course, finalizing the classification work we are doing for classifying glass files, for classifying point clouds, providing more support for the level of for the management of the level of details, and there are some activities starting during the next few weeks for providing support for other common data formats like the one you can see here in the list. There are, of course, as usual, online resources that you can consult and you can check out for testing, of course, the Digital Twin Toolbox standalone. But the main ones related the integration of the integration with geOrchestra are reported in that slide. Okay. Thank you so much.